Today we are reviewing the Pythagorean Theorem. You would have first experienced the Pythagorean Theorem in grade 8 and again last year in grade 9. As we know, the Pythagorean Theorem can only be used with right-angled triangles. In other words, our triangles have to have 90-degree angles in them to be able to use the Pythagorean Theorem. And also important to know is that the longest side in a right angle triangle is called the hypotenuse. So you can fill the blanks in. It is the side across from the 90-degree angle. It's the one that doesn't make up the 90-degree angle. It's not attached to the 90-degree angle. It's across from it. And our Pythagorean theorem says in a right angle triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides. Or more succinctly, we've got the hypotenuse squared is equal to a shorter side 1 squared plus another short side 2 squared. Or we may have used this theorem or formula in the past. H squared is equal to a squared plus b squared. Sometimes teachers will use c squared equals a squared plus b squared. In any case, it all means the same thing. The key idea is the side by itself, squared, has to be your hypotenuse. It has to be the longest side. Okay, so if we look at this first example, we want to use the Pythagorean theorem to determine the length of the unknown side. So in this triangle, I need to find the length of the side here, which is across from my 90-degree angle, which means it is the hypotenuse. So I could use my x squared by itself is equal to the squares, the sum of the squares of the lengths of the two shorter sides. So we're going to have 5 squared plus 12 squared being equal to x squared. Now if we calculate that, 5 squared really means 5 times 5, which is 25, plus, and then 12 times 12 is 144. And if we add those together, we get 169, which actually is a perfect square. To get x by itself, right now it's being squared, we're going to actually square root both sides, and we get x being equal to 13 centimeters. So our hypotenuse is 13 centimeters. Try the next example. Put me on pause. Come back to me later. Okay, in this triangle, I meant to mark that as our 90-degree angle. Now, given that, this side across from it should be our hypotenuse, and that's our unknown side that we need to solve for. So this will be my x, and so my x squared is going to equal the squares of the other two sides added together. So 16.8 squared plus 7.1 squared. Now on my calculator, I'm going to do 16.8 times 16.8, or use the square button, and I got 282.24. To that I'm adding 7.1 squared, which is a 50.41. And when we add those together, as long as I didn't punch anything in my calculator incorrectly, I got 332.65. So that's x squared. That's what x squared is equal to. At this point, I need to get x by itself, so I'm going to square root both sides. And when I do, I get approximately 18.2, if we round that correctly. And I just went to one decimal place because the question, the side lengths in the question, were both to one decimal place. Okay, next example. Part C. Again, I didn't put my right angles in here. I forgot. Well, it's hard to do them on the computer, so there we are. The right angles are in there. Now, what I have is I'm going to figure out which side my hypotenuse is, and in this case, my 22.3 is my hypotenuse. So it actually is the side by itself, 22.3 squared, has to equal my other two sides squared, so 15.7 squared plus my unknown side, which I'll call x again, x squared. Putting that stuff into our calculator, 22.3 squared, I got a 497.29 is equal to 15.7 squared is 246.49 plus x squared. Okay, and then to get x by itself, I'm going to subtract the 246.49 from both sides. And I'm going to put those numbers together, 497.29, subtract 246.49, and I got 250.8. 250.8 is equal to my x squared. And again, I want just an x, so I'm going to square root both sides. And I've got the number left in my calculator, so it was easy to do. Just hit the square root button, I don't have to retype it. And I got x being approximately equal to 15.8. And again, I'm going to 1 decimal place because the numbers on my side lengths of my triangle were 1 decimal place to begin with. Okay, you try the next one. Put me on pause and try it. Okay, hopefully you've tried this example. We know from here, I'm trying to find that side, the 5.8 is across from the 90 degrees, so it's going to be the hypotenuse. So when I set up my equation, I should have my 5.8 squared by itself equals x squared plus 4.1 squared. Put some things in the calculator. 5.8 squared is 33.64 equals x squared, and then 4.1 squared is 16.81, and then we're going to subtract the 16.81 from both sides, and that leaves me with x squared on the right side of the equal sign, and then I have 16.83 on that side, and then we're going to square root both sides, and you should get 4.1 approximately. So it's almost a isosceles triangle where 2 sides are the same length. In fact, when we round it, they really do look the same. My diagrams are never drawn to scale, so that's why it looks the way it does. And then we get into an application. We have a 22-foot ladder leaning up against the wall. So one of our strategies when we're solving is draw a diagram. So I've got my wall and the ground. They should meet at 90 degrees. The base of the ladder is 5 feet from the bottom of the wall, and the ladder itself is 22 feet. So I'm thinking my ladder is kind of something like that, 22 feet here. And this distance here is 5 feet. That was supposed to be an arrow pointing up to that length. All right, and we want to know how far up the wall the ladder is going to reach. Based on my diagram, this side is my hypotenuse. The ladder is the hypotenuse. And when we fill in, the hypotenuse squared is equal to the sum of the squares, the sum of the lengths of the squares of the lengths of the other 2 sides. So we end up with that. 22 squared is 484, and 5 squared is 25. And then to solve for the x, we're going to subtract 25 from both sides. And we get 459 is equal to x squared. And then we can square root both sides. And we get x being approximately equal to 21.4. So therefore, the ladder will reach 21.4 meters up the wall.